All right, here's a couple of good questions. I think both mass stoichiometry. So it says I've got a sample of potassium chlorate decomposed, and according to this unbalanced equation. All right, so let's balance it. So I have 1K, 1Cl, and 3 oxygens. Over here, I've got 1K, 1Cl, got but 2 oxygens. So I've got to get some kind of balanced or common denominator there. Probably go to 6. So let's put a 3 here. That'll give me 6 oxygens. So what do I need to put there to get the 6 oxygens? Hopefully you said 2. That would be good. Okay, 2 times 3, that'll give me 6 oxygens there. But it also gives me 2 KCl's, so if I put a 2 there, then the whole thing's balanced. Okay, that's first and critical stage. You've got to get that. Then I write down underneath each thing what I have and what I'm looking for. So it says I have a mass of 1.9 grams of that stuff. And the question is how many moles of this stuff are formed. Perfect. So I'm starting in Solidsville, and I'm going to have to convert that to moles. That'll be step 1. And then I'm going to have to take that moles and convert it to moles of KCl. That'll be step 2. And they say to stop at moles. So just a 2-step question. Good. So step 1 is to take the mass of KClO3 and convert it to moles of KClO3. Okay, so to do that, I need to use this formula. Mass over molar mass. The mass is 1.9 grams. The molar I don't know that. Let's go over here. So I have 1 potassium, 1 chlorine, and 3 oxygens. So potassium, I think, is 3910. Chlorine is 3545. And oxygen is 16, but there's 3 of them, so that would be 48. So when I add these together, I get 55 there. And then 17 plus 5 is 22, I think. Is that right? 8, 13, yeah, it's 22. And then a 2 here, so it's 3, 6, 7, 8, plus 4 is 12. 122.55. So 122.55 grams per mole. Those are the units for molar mass all the time. Grams cancel. I'm going to come up with moles. Let's put that answer in calculator. So I've got 1.9 divide 122.55. So I'm getting 0.0155, etc., moles of KClO3. Okay, step 2, I'm going to take the moles of KClO3 and convert it to moles of KCl. And to do that, I use the molar ratio. So I write down what I have, 0.0155, etc. Keep that number in your calculator, of KClO3, times by the mole ratio. And the mole ratio are these numbers here. Oh, it's the same number. Nice. So I would say 2 KClO3 moles produce 2 moles of KCl. So the moles of KCl cancel out. And so if I multiply by 2, divide by 2, I'm going to get the same number, 0.0155, etc., moles of KCl. And that gets me to this step right there, and that's where they tell me to stop. So let's round to Sig Figs. I got 2 Sig Figs here. So in my answer, I need 2 Sig Figs, so it'd be 0.01. And then I need to look 1 past that. It's 5 or more, so I bump that up to a 6. Moles of KCl. So you notice my mistake in the question. I should have had another 0 in there. That's a good one. Let's try this one. Ethene Burns. You can look up ethene in your periodic table, but I think ethene is C2H4. And if it burns, maybe it's a gas. If it burns in oxygen, and it always produces, it's a hydrocarbon, so it's going to produce carbon dioxide and water. Okay, now I need to balance the chemical equation. I've got 2 carbons, so I'll put a 2 here. That gives me 2 carbons. I've got 4 hydrogens, I'll put a 2 here. That gives me 4 hydrogens. Now, 2 times 2 gives me 4 oxygens, plus another 2 oxygens here. So that's 6 oxygens altogether on the right side. So what do I need to put here to get 6? Hopefully you said 3. That would be good. Okay, so there's my mole ratios. Let's write down what we have. So 6 grams of CO2. So that's over here. Mass is 6.0 grams. And then they say how many grams of ethene reacted. So they want to know the mass of this that reacted. Okay, so I'm starting at Solidsville. You can't see that. I'm starting right there. I'm going to have to go down to moles, step 1. Go from this moles of carbon dioxide over to this moles, that's step 2. That's of ethene. And then finally I have to go from moles up to solid. That'll be step 3. Okay, the stuff on the left side is the carbon dioxide side, because this is what I'm given. And over here is what I'm asked, and so that this side over here will be my C2H4 side. Okay, so let's go ahead and do it. Red. So I want to take mass of CO2, and I want to convert it to moles of CO2. Okay, because they gave me a mass, I'll convert it to moles. Formula is moles is equal to mass over molar mass. The mass is 6.0 grams. The molar mass of carbon dioxide, I got to figure that out. 1 carbon is 1201. 2 oxygens are 32. Each oxygen is 16, so 2 of them is 32. So if you add that, I get 44.01. So divide by 44.01 grams per mole. Grams cancel, calculator. So I have 6 divided by 44.01. So I'm getting 0.13633, etc. moles of carbon dioxide. So step 1 up here, done. That step's done. Now let's do step 2. So I'm converting moles of CO2, that's what I'm given right there, and I'm converting it to moles of ethene. So convert that to moles of ethene. Okay, like all mole ratio questions here, I start with what I'm given, 0.13633 moles of carbon dioxide. Now I multiply it by the mole ratio. So I want moles of carbon dioxide on the bottom, and what I'm looking for is moles of ethene. That's going to go on top, C2H4. So carbon dioxide is 2, and ethene is 1. Okay, so take the number you have on your calculator, times by 1 and divide by 2. You should get 0.06816, etc. moles of ethene. Good, so I look at my river, and I've just crossed the river, so I'm right there. So my last step is to convert that back into grams. So step 3, I'm going to take moles of C2H4 and convert it to mass of C2H4. To use that formula, moles is equal to mass over molar mass. I'm searching for mass, so mass will be moles times molar mass. The moles are right there, 0.06816, etc. keep that number in your calculator, times, the molar mass of ethene. I don't know that. But I know there's 2 carbons and 4 hydrogens. Carbon's 1201 times 2 would be 24.02. Hydrogen's 1.01 times 4 would be 4.04. So it looks like I've got 28.06. So this would be 28.06 grams per mole. Okay, so take what's on my calculator and just go times 28.06. And I'm getting 1.91274 grams. The moles will cancel. Okay, Sig Figs. I look at my question. Looks like I just have 2 Sig Figs. So I'll round this to 1.9 grams. And if you take a look, that's what the answer is too. All right, hopefully you see that. And it's important to get that pattern and get that logical progression of what you have to what you are asked to get.